Today we'll have more example on evaluating differential equation, which is also known as separable equation. Now in this problem, we need to find the equation of the curve passing through the point 0, 7, and whose slope at x, y is given by 4x cubed y. Now we're going to follow the three steps that we did in the past to be able to answer this particular question. Now the first step is to find the function by integrating our slope using the technique that we have learned from the previous lesson. So we have dy over dx equal to 4x cubed y, and to find the function y, we're going to integrate the left side and the right side of our differential equation. But before we can do that, we need to group our dx and x together and our y with dy together. So by cross multiplication, we'll have the integral of dy all over y equal to the integral of 4x cubed dx. Now we can integrate our left-hand side and right-hand side by the technique that we did before. So the integral of dy over y is simply ln of y, or ln of absolute value of y, and the integral of 4x cubed dx is equal to x to the fourth plus c. And that is the first step in evaluating this problem. Now the second step is to find the constant c from our function, and to do that, all we need to do is to replace the function ln of absolute value of y equal to x to the fourth plus c by the point 0 and 7, which is your x and y respectively. So ln of y is now ln of 7 equal to 0 raised to the 4 plus c, which now gives us the constant c, which is ln of absolute value of 7. So now that we have our constant c, we're going to replace our c here by ln of square root of 7 and simplify the function so we can find the value or the function y. So now we have ln of absolute value of y equal to x to the fourth plus c, replacing c by ln of 7. Now we have ln of absolute value of y equal to x to the fourth plus ln of absolute value of 7. Now, in this particular step, we know we can still further simplify our function by evaluating our ln. So we need to get rid of our ln by multiplying both sides by ln or by e, so we can have e raised to ln of y equal to e raised to x to the fourth plus ln of 7. Now the reason why we're doing this is we need to find the function y in this equation, and in this particular technique we'll be able to find the function y by raising both sides by the constant e. So e to the ln of absolute value of y is simply absolute value of y, and e raised to x to the fourth plus ln of 7, by the laws of exponents, we can separate this exponent into e raised to x to the fourth times e raised to ln of 7. So we know that e raised to ln of 7 can still be simplified, and by getting rid of e to the ln, we'll have absolute value of 7. By just copying the rest of the problem, we'll have the absolute value of y equal to e raised to x to the fourth times the absolute value of 7, which gives us the function of y equal to 7 times e raised to x to the fourth, which is true to the function that we are looking for. And that is how we use this particular technique on how to evaluate differential equation. Now let's have our second example. Now in our second example, we have our equation of the slope of the function, which is 5x square root of y squared plus 3 all over y, passing through the point 2, 1, or the coordinate 2, 1. Now, the first step that we're going to be working on is to integrate our function so we can find our function y. So we have dy all over dx equal to 5x times square root of y squared plus 3 all over y. Interchange or group our y's and x's together, so we'll have the integral of y dy all over the square root of y squared plus 3 equal to the integral of 5x dx. Now, on this side of our equation, it's easy to integrate this function because the integral of 5x dx is simply 5x squared all over 2 plus c. Now, we're going to have a more challenging function on the left side of the equation, and in finding the integral of this function, we will be using the technique that we have learned before that we call the substitution method. So for this particular function, we are going to set y squared plus 3 as our u, and finding its du, we'll have du equal to 2y dy, which we can simplify as 1/2 du equal to y dy. And by the substitution method, we can change y dy into 1/2 du, and we can change square root of y squared plus 3 into u raised to 1/2. So now we have 1/2 integral of du all over u raised to 1/2, which we can rewrite as 1/2 times the integral of u raised to the negative 1/2 du. Now that it's a little bit easier to integrate, we'll be able to find the integral of this function using the substitution method. And here, 1/2 times the integral of u raised to negative 1/2 du will give us 1/2 times 2u to the 1/2, which when you simplify will only give you u raised to 1/2. And we know that our value of u is y squared plus 3, and 1/2 can be changed into a radical. So this side of your equation a while ago, the integral of this function is simply the square root of y squared plus 3. And the integral of 5x dx will give us 5 over 2x squared plus c. So now that we have our function y, we'll have to find the value, now that we have our function, to find our function y, we need to replace, or the constant c, we need to replace y and x by 1 and 2 respectively. So y becomes 1 and x becomes 2, and by simplifying this function, we'll be able to find the constant c, which will give us negative 8. And now that we have our constant c, which is negative 8, we can complete our differential equation by replacing our function, this function, for c is equal to negative 8. So our equation for our line will be equation for our y function is square root of y squared plus 3 equal to 5 over 2x squared minus 8. And this is our example number 2. Now let's have our example for this particular lesson, and this time let's find the equation of, or the function y, given the equation of the slope, which is x squared all over y squared, with the initial condition of y of 0 equal to 2. So the first step is to separate the equation, and we'll have square or integral of y squared dy equal to the integral of x squared dx. Now the integral of the first, or the right hand side, will be y cubed all over 3 equal to x cubed all over 3 plus c. Now if you'll notice, we still have 3 in our denominator, and to get rid of that denominator, all we need to do is to multiply both sides by 3. So by multiplying both sides by 3, we're eliminating our fraction form, and we will end up with y cubed equal to x cubed plus 3c. Now the constant c is what we need to find on our next step. But since it has a coefficient of 3, and since it's just a constant, we can change 3c and replace it with another variable. And now let's say 3c is equal to k. So now we're just going to look for the value of the constant k using this technique. But first, let's figure out a way on how to isolate y in this particular equation. So if we have y cubed minus x cubed is equal to k, to isolate y, all we need to do is to take the cube root of both sides of the equation, considering that x or negative x cubed is already with k. So now y is equal to the cube root of x cubed plus k. Now what we need to do now is to find the constant k by replacing our y and x by 2 and 0. So from the initial condition, we're able to find the point where that function is passing through, which is 2 and 0. So now we'll have 2 equal to the cube root of 0 cubed plus k, which will give us 2 equal to the cube root of k, therefore k is equal to 8. So now that we have our constant, we are now ready to change our function and complete it by replacing k into 8. So now our function is y equal to cube root of x cubed plus 8.